Okay, let's do this question. So we have this set is a basis for an inner product space. Okay, so we can use inner product here. Show that the only vector that is orthogonal to all the basis vector is the zero vector. Okay, of course, for the zero vector, it is very clear because we know that 0 and inner product with Vj will be 0 for any j from 1 to n, right? So we want to show that this 0 is the only vector that if I take the inner product with Vj, I will get 0. Okay. So I want to sort of prove this by contradiction. So suppose that I have another vector. Okay. Suppose that there is a vector v, okay, that is not the zero vector, such that v inner product with Vj is equal to 0 for any j from 1 to n. Okay, suppose that we can find another vector. Okay, and I want to find a contradiction. Okay, if there is a contradiction, means there is no other vector other than the zero vector such that the inner product is equal to 0. Okay, so how can we do this question? Okay, we need to make use of this information. Okay, it is a basis. Okay, so note that we can write this v, okay, in the form of k1 v1 plus k2 v2 plus and so on until kn vn. Okay, for some k1 until kn. Okay, because it is a basis. Okay, then what do we have here? We have the inner product of v and vj is 0. Okay, this is our assumption for any j. Okay, so imagine if I take the inner product with Vj, this will be 0, but then this part cannot disappear. Okay, because this is not an orthogonal basis. Okay, so it is not so good. But if we take the inner product both sides with v, let's say, so the left hand side, of course, it will not disappear, but the right hand side, okay, on the right hand side, I will have the inner product of v and v1, v and v2, and so on until v and vn, and all of v and vn, okay, and all of them are zeros. Okay, so maybe it is better, I don't know, but we can try take the inner product with respect to v. Okay, so we have k1 v1 plus k2 v2 plus and so on until kn vn v, and we see that this will be k1 v1 v, sorry, plus k2 v2 v plus and so on until kn vn v. Okay, and all of these, okay, all of these are zeros, so this is equal to 0. Okay, very good. So we have, okay, so we have vv is equal to 0 Okay, this implies my v must be the zero vector. Okay, my v must be a zero vector. This is by property 4. So it is a contradiction since I want my v to be non-zero vector. Okay, so what is the conclusion? The conclusion is, which is a contradiction. Okay, hence, okay, there is no other vector other than 0. No vector, okay, other than the 0 vector that is orthogonal to all the basis vectors. Okay, good. It is clear, should be clear.